revise whatever we have done, but it's very small thing that we have done. So that is, after we lose some data file on the primary side, without using the backups, how can we get back that particular data file? By using standby data file is what we have learnt in the last class. Similarly, now in today's class, we will do the continuation on top of it. What is the continuation? If the standby data file is lost, what to do is what I'm going to discuss. But definitely, if the standby data file is lost, you no need to worry about the ongoing process. You no need to worry about the end user unavailability, because it is only the standby environment. So in case a data file is lost on the standby environment, don't be panic first of all, because it is only a standby environment, not the primary database. So you are not getting downtime to the business. It is only a pause to the business, you can call, if there are any reportings running on the standby. But now I will be telling you what are the different ways of actually restoring a lost data file on the standby environment. First thing is, if all the archived redo log files needed for the recovery are on the disk, what is that you have to say? Restore the data file by using restore data file command. Why? As the backups are there on the standby side, you can just say restore data file command, and then you can start the recovery process. And if all the redo logs files needed for the recovery are not there on the disk, then you will have to restore the data file, then recover the database command until that SCN number, and then start the redo apply. Because you are on the standby environment, redo apply is also very, very important. So that's the reason, if the restore data file is something that if all the archive redo log files are there on the disk, then definitely you just require to restore the data file and start the redo apply. Then it will automatically pick up all the redo contents from the archive log files, and it will recover the data file when you start the redo apply. But if the archived log files are not there on the disk for the recovery, then you will have to restore the data file, recover the data file, and then start the redo apply. And you can use a current data file from the primary database also. So how can we do that? I will showcase now. So this is my primary database environment. I'm starting my primary database listener, and then database, primary database, you can just make it a startup. Now you can open your standby database environment. Set up the environment variables, bring up the listener, and then mount the database. After mounting up the database, then what is that you have to do? You can just start the recovery on the standby. So after I start the recovery, I will leave it for a while so that it will come into sync after a while. So alter database, recover managed standby database using current log file, disconnect from session. So alter database, recover manage standby using current log file, disconnect from session. So let it start the recovery and let it come to in sync in a meanwhile. But let me explain you what is that I'm going to do going ahead. So once this is done, just try to connect to Armin on the standby side and just try to see what are the backups you have got on the standby so far. Just give list backup. So these are the backups that you have got on the standby so far. But please remember, the control file is taken from your standby and primary database. So that's the reason you will have all these things. But now, if you wanted to have a proper backups in place on the standby environment, what is that you have to do? Backup as compressed backup set database plus archive log delete input. Let us try to take a full database backup on your standby database side. Please remember, we are taking the backup on standby database side. So the backup is completed on the standby. So just come out of this, and then what is that you do? Let us now try to see if these backups are, sorry, if these standby database is in sync or not. So let me try to check the health with my same script running on both primary as well as on standby. So it is in sync. I'll also try to do a switch and try to check here if 13 is there. Yes. So now these are in sync. Now being these things in sync, what is that I am saying? I will select one data file and I'll lose it. $v data file on standby. Please remember, I am doing this on standby. Just remove this. Definitely there is an issue in the recovery. Then what is that you have to do? Just connect to the database and stop the recovery first. Alter database, recover, managed, standby database, cancel. Once you cancel this, then come back and connect to the rman and then say restore data file 4. Restore data file 4. After that, just come back and then say in the SQL prompt, because all the archive logs are there on the disk. So alter database, recover, managed, standby database until, alter database, recover, manage, standby database using current log file, disconnect from session. After it starts, just try to monitor your log file so that you should not see any errors there. Oracle, base, and diag, and RDBMS, DGDB2, trace, tail hyphen 20 alert log file. So media recovery has been started, and then media recovery here is waiting for the thread sequence number, and it is started here. So you can see that blockchain tracking file is current. So tail hyphen 40 alert log file. Just try to see. You can see that full restore of the data file is what I have done here. So that is what I have first of all cancelled it. Then I have done the restoration of the data file, and the checkpoint on top of this data file is this. And then when I started the recovery again, it started attempting to do the recovery using the real-time apply from the archive log files which are there in the archived location. So then now back into sync. So this is what I have said in the process. Now if you try to check what is the sync, is these things are sync or not. On the primary it is 13 here, and on the standby it should be 13. And if you do the alter system switch log file without any errors, I should be able to see that it has been recovered successfully to the 14. But if the that particular data file, if it is not existing, definitely you will see an error of recovering it. But you see here, without any problem, it has been recovered without any errors here. So that means you are able to recover the data file successfully on the standby database side also when it is lost. So the next concept for us to understand, we have understood what to do if there is a loss of data file in the data guard setup, but if there is any blocks that are corrupted, not the complete data file, if you find a single block or a multiple blocks in a single data file as corrupted, can we take the advantage of the same data file which is available in the other databases in the data guard environment? What I mean is, if we have the blocks corrupted on the primary side, can you make use of recovering that block using the standby data file? Similarly, if there is a block which is corrupted on the standby, can you take the advantage of recovering that block from the primary? This is what I am trying to show you. But This is done automatically in 11G database. So what is that you can see on the screen? The same thing. A corrupted blocks in the primary database are automatically repaired by using blocks from the physical standby database. And real-time query and active data guard environment must be enabled on the physical standby database. Only then automatically blocks will be repaired on the primary database server side. I'm repeating it again. Only when you have real-time apply as well as active data guard using on the physical standby, only then the blocks are automatically recovered on the primary using the standby. This is the enhancement that you can see. And similarly, if there are corrupted blocks in the physical standby environment, they are automatically recovered from primary database. And definitely the prerequisite is there should be real-time apply and also active data guard configuration on the physical standby. Only then the blocks corrupted on primary will be recovered automatically from the standby. Similarly, the blocks corrupted on the physical standby are automatically recovered from primary. Without having real-time apply and active data guard environment, the blocks are not automatically repaired either from primary or standby. Please remember this. This can be an interview question. I'm repeating it again. If there are any blocks corrupted either on primary and standby side, they can be resolved or can be recovered automatically only when you have real-time apply and active data guard environment set up. If you don't have real-time apply or active data guard environment, the corrupted blocks are either on primary or the standby will not be able to recover automatically. That is the statement. And if in case, if you do not have real-time apply and data guard environment, how can you repair a corrupted block? You can say recover data file 6 and block number 3. This is what you can do it. And if you have multiple blocks, you can give the multiple blocks here just like this. But please remember, whenever you run a recover block command on the primary database side, by default, it will go and try to do the recovery with the help of standby data file. To avoid that, after the recover block, you have to say exclude standby so that it will not go to standby and perform the recovery on the primary. I'm repeating it again. If you do not have real-time apply and active data guard environment, definitely the corrupted blocks are not recovered automatically. In that case, you will have to manually recover the corrupted blocks. The rman command which is already there to recover corrupted blocks is recover data file number followed by block number. But in the data guard environment, if you issue this, automatically it will try to recover that block from the standby, but it will not be possible. In that case, to recover the block excluding the standby, you will have to issue exclude standby at the end. Only then recovery will be started on the primary side without checking the blocks on the standby side. Please remember, this is a very, very important statement, and this can be used in real time also. But why I will not be able to showcase this is I am unable to corrupt a single block to showcase. So once I get some way to corrupt a single block in a data file to showcase this exercise, I will definitely record that and I will be sending you. But the process is, as I have told you, if you want to recover a data file and if you don't have active data guard or real-time environment, real-time apply, you have to only use rman to recover that block. But when you issue recover block, it will definitely try to recover from the data standby data file. To exclude that, you will have to issue exclude standby at the end. Now, if that is very clear, now we will have to understand how to manage client connectivity. Why should we worry about understanding how to manage client connectivity? First of all, let me explain the chapter. This current chapter is to let you know how to configure a proper application server so that it speaks to primary database when your data guard environment is healthy. But whenever there is a switchover or failover activity, it has to automatically point to the failover or the switchover environment. What I mean is, when you have the data guard environment, you have primary database to which application is directly connected and it is working on top of your primary database. But when switchover operation is performed, Now the primary database is not DB1, the primary database is DB2. Then how does application server will know that it has to connect to DB2 instead of DB1? That is what the current chapter will explain you. How can we configure a proper client connectivity for a data guard environment is what the current chapter will deal. Let me make it little clear. For example, we have a primary database of DB1, standby database of DB2. When the data guard environment is healthy, always the application server will try to connect to the database called DB1. But whenever you perform a switchover operation, DB1 will become standby, DB2 will become primary. Now the application server should not connect to DB1, but it has to connect to DB2. How can the application server knows that it has to stop the connection to DB1 and it has to try the connection to DB2? How is it possible and what are the different ways to make it possible is what the current chapter will deal with. So we have to be aware of the following issues whenever you are trying to configure a proper client connectivity and data guard. What are they? You have to worry about the databases residing on different hosts in data guard configuration. And the clients must connect to the correct database, whether it has to be primary or logical standby or snapshot standby or physical standby with real-time query is also called as active data guard. And the next thing is, that is what it is. Now, if the client send communication request to the wrong host, they may be connected to the wrong database or receive an error. So the clients must automatically reconnect to the current database in the event of failure. For example, as I have been telling you, when the primary database has been switched over to the standby database, then definitely from that moment, the connections has to be redirected to the new primary. So how can that happen is what I am going to explain now. So let us understand this client's connectivity first of all. You know, this is an application server. This is the primary database to the left side of this dotted line, and to the right side of this dotted line you have standby database environment. You know what is using local naming. If you have taken my real-time activity course, you must be understanding what is using local naming. Local naming is nothing but using TNS entries where DG_prod is nothing but the TNS entry or the service name of your primary database. For example, this is the application server that you are seeing on the screen here. If it is using a service name called DG_prod, that DG_prod is the service name which is hearing on the listener on your primary database alone. Then, whenever the application server is trying to connect to the database using this service name, it has to automatically point the connection to the primary database. That is what you see on the screen. This is what happens in reality. And as per the data guard environment, this particular database, which is primary database, has got another setup somewhere far from the current location, that is called standby database, in which the data which is being modified on the primary has been or is being applied continuously on the standby environment. This is our consideration first. Now how can we prevent the clients from connecting to the wrong database? What are the different possibilities? You have to use database services to prevent clients from connecting to wrong database in the data guard configuration. So what is the first best solution to avoid clients to connect to the wrong database? You have to use a proper database services as the first priority. And these database services acts like an abstraction layer between the client and the database instance. Just because if you have one service name which is called DG_prod, if that service name is being only heard or heard on the primary or on the standby only on one of these database servers, then definitely there is no chance for the end user to connect to the wrong database. So you have to register those services with the listeners also. And the next thing is clients connect to the database services instead of database instances. As we know already, when you go to the listener control and if you see the status of listener, you can see that database name is the default service name in the listener. But that is not the best practice in the data guard environment. That's what I'm saying you. we have to create a database service which is dedicated, and it can only hear on either primary or on standby. If you are creating such service names dynamically, then you are having a best configuration in DataGuard environment. Because if you just try to see listener status here, DGDB2 is the service name, and this will connect to DGDB2 database here. So that's the reason you have database names, unique names in the listener automatically registered by the PMON. But please do not try to use the service names for your applications which have come by default as the database name. And the listeners use registration details to determine which instance support a particular service at a particular moment of time. Listeners will then redirect the connection request to the correct instances, otherwise to the appropriate error is returned. So how do we manage and create services is what I'm going to explain now. So what is the package that is used to create dynamically a service and to stop a service? It is called dbms underscore service. So this is the package which we will have to use, and this is used to create the services, register the services, and then try to move the services to the standby whenever the standby or the physical primary becomes standby and standby becomes primary. What are the attributes for the service names? You have to give a name to the service and a network name to the service, and if you are using TAF, if you are having a rack environment, then you can create a service name with TAF attributes also. Now you see, instead of using a local naming convention, you have to use database service name, which you have created by using dbms underscore service package. Please don't think that I'm only doing some theory part, but definitely I'll be showing you that in reality also. That's the reason I have got all these things in place. So how do we create a service in the DataGuard environment? Just try to run these things. There are different ways of creating a service. As I am giving you as an example, let me show you what are these things, then you will understand. I'm using dg underscore prod as the service name for an normal physical standby database environment, and I'm using something else called dg underscore rtq for your real-time apply DataGuard environment. I'm creating some other service called lsby. This is for the logical standby environment, and I'm creating another service called snap. This is for your snapshot standby environment. Please remember, all these things are not necessary. This is necessary because at the moment I have got only normal physical standby DataGuard environment in place. So that's the reason. What is that I have to do? Connect to the database environment and try to run this. So you have to say execute and then followed by this one. Once you have done this, see what happens. Now you say exit, and then you say lsnr status lsnr underscore dgdb1. After creating the service, it is our duty to start the service. So that's the reason when you see lsnr status listener name, you do not have that service name called dg underscore prod anywhere in the service name list. So that's the reason after you do this, you have to start that service name. So how can we start the service? Again by using the package dbms underscore service. So I have to say and then start underscore service and then followed by the service name. So what is the service name? dg underscore prod. Now you come back and see lsnr status lsnr underscore dgdb1. If you see here, you can see an additional service name called dg prod has been added to serve the database name called dgdb1. So this is what you have to understand. Not just creating the service name, but also to start the service name is very, very important. Only then that service name can be used by the end user to connect to the database DataGuard environment. Let me show you that one also, but after this. Actioned actioned output. Fine. Now you see here. Now after I do this, now let me come back to my normal database, I mean data on my Windows machine, considering my Windows machine is my operating or my application server. Consider this is my application server, and I have to go to the location where I have my Oracle client installed. If you see here in this TNS names, I have added a TNS entry here called connect. So it's short form as con. So if you see here, I'm giving the host IP as our primary database server IP, but instead of using DGDB1 here, I'm using the service name that I have created just now. So that means if I go to the command line here, and if I try to connect from the SQL Plus using this service name, using this TNS name called CONN, it will try to connect to the database with the service name called DG_prod. So if I SQL Plus /s, okay, SQL Plus system / Oracle 123 at connect. Okay, I think system spelling is wrong. So it has connected. Now we are very much sure that the connection has been established on the primary database because the service name called DG_prod is running only on the primary database. You can see that here, right? It is running only on the primary database. But now if you connect to the database, and if you stop the service, for example like this, if you stop the service instead of started, you just started, we know that. So instead of starting, you just stop the service. And now if you try to connect from the application server again, you will see that there is an error here. What is that? Listener does not know the service requested in the connect identifier. What is that I am trying to showcase in this example is, whenever you have a proper control on the service names, you can stop and start the service whenever before you do a switchover or a failover operation, so that this particular service name called DGprod will hear only on either primary database or on the standby database, so that you will be safe in hands by not connecting to the wrong database environment from this client side. So that's the reason creating own service names in the data guard environment is very, very important, and you will have to have only one service name which is on the primary database, only on the primary database after you do a switchover or after you do a failover operation. This is very, very important for you. And please remember, once you start the service or once you create a service will be created on your standby database also, but it will not be hearing there. The service will be started on the standby only after you forcibly start the service on the standby. How can you automate this? Can be your next question. So we will deal how to automate this particular service name creation on the standby whenever you perform a failover operation. I'll tell you the possible ways now. So the different ways of starting up the service name automatically on the standby database side whenever you do a switchover or a failover operation is by creating a logon trigger or a startup trigger. So I think I have created here a startup trigger which will automatically start the service called DG_prod whenever it sees the current database role as primary. So whenever it sees the physical role as physical standby, and if it sees read-only mode on the standby environment, then it will start this one. But you will not require all these things. But what is the only thing that you will be required? If the role is primary, then definitely start up this service. That is what the trigger that you are trying to start up. So let me copy this until whatever we require here. And else clause, I'm writing it just now so that you also feel good of writing these things. Else I'm stopping it. Stop _ service dg underscore prod, and then end if, and then end. So what I'm trying to create, let me show you once I execute this. So I have created a trigger. Will this trigger will be available on the standby also? It will be available, but it will not be started. Why? Because DDLs will also be reflected on the standby, but I cannot query it at the moment because the database is not opened with read-only mode. But definitely whatever triggers you are created on the primary side, those triggers will also be created on the standby side. But why this trigger will be useful? I think if you have taken my real-time activities course already, I have clearly explained what is the purpose of creating a trigger which is a startup trigger. That means once the database has been started, what is that I am writing in this trigger? Please, whenever the database is in open mode, try to see the role of the database. If the role of the database is primary, then you start the service called dg underscore prod. Else, stop that service called dg underscore prod. This is what I have created in the trigger. Then did you understand the statement that I have shown you? What? dg underscore prod should be the service name which should only be running on primary database. This is what I have said so far. Is it not, will it not work with the help of this trigger? Definitely it will work. So whenever your database is converted from primary to standby, what happens? It will automatically stop the service on the standby side, because the role is not primary. Similarly, whenever database is switched from physical standby to primary, it will automatically start the service because the current database is primary. This is how, what is that I have told you, the solution? The solution that I have told you so far is only to start and stop the service according to the requirement. That's it. What is the solution? Trigger. This is the only solution. So the solution, by having a proper solution here, you can actually control how and when to stop a specific service on a database based on the role of the database. That is good. Excellent. We have done an excellent job of actually controlling the services on the primary side or on the standby side. But did you think about TNS entry here? Whenever there is a switchover operation, the host is no more 150. The host is now 151 as an example. So when the host is no more 150, if it is 151, then how can the application server will connect to the second server instead of first server? You have to give an additional entry in the same address line. That additional entry should point to the host name of this, that is 151. Hopefully 151 is the IP address of this. Yes, it is 151. That means what is that we are trying to tell in the TNS names? First try to connect to the first server. See that if you are able to connect to the service name called dg underscore prod. If you do not find dg underscore prod on the server number 1 here, then go and try to connect to second server with the same service. So definitely, as I have created a trigger there, this service called dg underscore prod will be either running on this server or this server because of the trigger that I have created. So what happens in that case is, definitely if the application server is trying to connect to the database environment, first it will try to go and connect to this server with this service name. If this server is behaving like the primary database, then definitely it will go and establish a connection on this server. But if the service name is not running on this server because of the trigger, it must be running on the second server. Then it will try to go and connect to this particular server and it will try to identify where is the service name on this server. If the service name hearing on this server, then it will go and establish the connection. If it is not, it will not establish the connection. You have to remember these things, and along with this, one more point that you will have to specifically remember is, after a failure is identified in connecting to the first address. To go to the second address, by default, it will take 10 minutes of time. So no one will be happy to wait for 10 minutes to go to the second address if the first address is not functioning. So how can this be controlled? This can be controlled with the help of writing something in sqlnet.ora file. Where is that sqlnet.ora file? So in the sqlnet.ora file, you have to give this to 3 seconds or 2 seconds. So where is the sqlnet.ora file? We already know it is here. So you have to say that sqlnet.outbound connect timeout should be only 3 seconds. So now I will tell you, though there is a issue in saving it automatically here, what is that I will try to do in the next session is, I will try to create an sqlnet.ora file. I will try to create 2 entries here. I will do a switchover operation, and then I will literally show you if the database is being connected to the new primary database or not with the current setup that I have created so far. So this is how the theory classes says, but this image will definitely make some sense tomorrow or in the next session when I actually perform a switchover operation, and then I will literally show if the database connections from the application are pointing to the database 2 or not after performing a switchover operation. So please be ready for the next session where I will prove whatever I have spoke so far.